Good morning, good evening, wherever, and welcome to episode 87 of the Cloudcast. Tonight we're coming to you live from Citrix Synergy. I'm Aaron, and I'm joined by returning co-host Amy Lewis.
Hello.
And Amy, this has been a good number for you now. You're giving Nick Weaver a run for his money for most co-hosts now.
I'm coming after you, Linksbat.
So tonight we're going to talk a little bit about cloud workload management with Matt Conover and Raj, both of you from Cloud Volumes. Matt, you're CTO.
That's right.
And Raj, you're CEO, correct?
That is correct.
Okay, and tell us a little bit, first of all, about the company, but also a little bit about this concept of application management that we were discussing about earlier.
Okay, so most fundamentally, we ask ourselves a very critical question up front, saying, why do we need to manage virtual machine as if they are physical machine? You know, the cloud, people thought clouds were made out of water, but actually cloud is made out of virtual machine.
Right.
Okay.
Right.
And they are virtual. Why do we manage as if they are physical machine? We install the application in it one at a time. We move them one at a time. We store them one at a time. It all costs, and there is no need to do so. That's where we started the company, and Matt has been developing this technology for the last 2+ years, and I came up with some very fantastic discovery and a simple conclusion. Virtual machine does not need to be managed physically.
Very cool. So Matt, elaborate a little bit more on that concept. What does that mean to say your average consumer out there?
Right. So the whole idea is to say, for example, if I need an application, maybe it's a web server, maybe it's a database, but basically if I need an application in 10 different virtual machines, do I really need to install it 10 times? And whenever I need to update it, do I need to go find all the places that application is installed and update it 10 times? So when we talk about workload management, what that really means is separating the workload from the virtual machine. Once you separate those out, it really doesn't actually matter what specific virtual machine my workload is running in. You know, if I put a workload on top of a virtual machine that I'm putting a database workload, that virtual machine is now a database. And if I take that workload out, it is now back to being just a generic virtual machine. So if really that's what our technology does, is to get you away from doing things per virtual machine. In effect, I make a workload container, right? That's what a cloud volume is. It basically describes the thing that contains your workload, and you can, in effect, plug that into any virtual machine in any cloud, private cloud, public cloud, doesn't matter. As soon as you plug that into a virtual machine, it basically becomes that workload. And so when I need to go and do an update my database, or I need to move my workload from my private cloud to the public cloud, I don't have to move the entire virtual machine. I really just take that workload, in effect this cloud volume, this container, and I can manage that thing. Right? So if I have a database that I'm sharing across 100 virtual machines, I don't have 100 copies. I have one copy of that workload that I can share across all of them.
Gotcha. Very nice, very nice. And Raj, you had a very interesting story earlier involving a customer and kind of use cases that you were sharing with us, and it was very interesting. Can you tell us a little bit about how it came about, right?
Of course. One fine day, on Friday morning, I get a call from one of the major bank from New York City, and this guy holds C-level title, fairly senior person in the company. He calls me and says, next week, can you guys come over to New York and meet with us? We are interested in your solution, and I know they have hundreds of thousands of instances, so it could be a large business for us. So I asked them that, you are a big bank. Why are you calling me as a small startup company? You could buy solution from anybody, and typically you always buy the products from a very large company. So why are you calling me? And the guy told me very clearly, he says, Raj, listen, if I had a solution from the large company which actually can solve my problem, I wouldn't be calling you.
Right.
The reason I'm calling you is the biggest companies are not solving my problem. I got a very particular problem in my implementation, and your company can solve it. So we really want you to have it. Sure enough, Matt and I packed up our bag, and next week we went over there, and we had one of the most amazing meeting with them. And we actually sat down together and concluded that they can get about 50% additional productivity using our solution. And we will keep working with them until they implement.
Very nice, very nice. So, Amy, you had Data Gravity himself on the podcast recently, Dave McCurry.
Yes.
And so we've often discussed on this podcast the concept of data gravity, that when you containerize, applications and things like that, or you containerize a lot and you kind of move them around, the one big thing that always tends to hold you back, though, is this concept of data gravity. And what I mean by that is, no matter how easy it is to move things around, physics limits you to size of pipes and data being in one place, right? And how does that concept or theory work into this? And is it positive, negative? Tell me a little bit about that with the containerization at the application level, right? What happens to the data?
Right. So there's a very good example here, which is, like right now, if you take something like a database, the actual size of that database can be very large, gigabytes or terabytes in size. But now if you think that when you take a virtual machine and you have, for example, a database installed in it, you're in a virtual machine, so that data physically has to exist on some disk somewhere. So now, if you imagine a case where you've got this database and you've got multiple copies of it, now what's happening right now is you've got these large databases, large files that are sitting on storage, and for each virtual machine, you've got an additional copy of it sitting on the storage. But there's really no reason you need to have. When I want to move something, there's really no reason I should have to go physically move something, because all of these virtual machines are sitting on the same storage. And by separating out that data from the actual virtual machine itself, when I want to go move something from this virtual machine to that virtual machine, I don't really physically have to move anything, because they're actually all under the same storage. And that's really, for example, what made vMotion from VMware, for example, so powerful. It's this idea of being able to move a virtual machine from one ESX server from one to another. Now, why is that so fast? Because they're not actually moving the virtual machine data. They're actually just, in effect, moving the association, but they're all sharing this storage, which is the SAN. Now, you can basically apply the same concept using what Cloud Volumes does essentially to applications or data, right? Because in that sense, we don't have the data stored in the virtual machine where it's tied its roots into that specific virtual machine. And so for me to move that somewhere else, I really have to kind of extract that and move the whole machine. In our case, a Cloud Volume essentially sits above the virtual machine. You plug it in, you unplug it, you plug it into something else. But when we're doing that, we're not actually really moving any data.
So you are taking the solution to the data as opposed to taking the data to the solution. Gravity.
Yes, that's a very good point.
Right. So there are 2 points. One of that you just hit the right on it. Data has become so large that there is no reason to move data where the application is. We need to move application where the data is. What it does say that application has to move instantaneously. Otherwise, people will wait. And as soon as the work is done, it should go away. The machine, whichever machine it was working on, has to become generic again so that another application can come in and do it. Many of the storage vendors are now actually building in the compute as a part of the storage itself.
Nutanix, for instance, or some of these others, right?
Right.
Yes.
So we are really set to take full advantage of it, because literally within a second or two, we can move any application, and even it might be a multi-tier complex server application, database, deep database or analytics kind of application. Within seconds, we can make it fully operational in any system, and then within seconds after the work is done, we can take it away as if it was never there.
Right.
So that particular aspect we have really understood and nailed it down. And that is the one aspect of the moving where the application where the data is. The other part of it is make the data appear without actually transforming. What happens is when people want to analyze the large data, they do not look at every piece of data. They look at the small piece of data, but it can be all over the place. So what happens if you only transfer what you need rather than transfer all and then test or look at only few things? We reverse the paradigm. We only transfer what it is needed. We make it appear everywhere so everybody thinks they have a full database. However, when you need it, we transfer only what you needed. And that's
is this effectively the computer science analogy of pointers versus static data, right?
Yep.
So it's all, and that's why you're saying you're able to reduce instances, right? Because all you're doing is replicating pointers back to an original.
Exactly.
Data
I mean, we think of it as kind of redirection. You go to read from here, and we've been just redirected to somewhere else in that sense. So, if I'm trying to read some data, if I want to actually move my database to the cloud, I might as well just send a physical hard disk to Amazon, for example.
Right.
You know what I mean? These days, it's still potentially faster and more cost effective to just put something on a physical disk and send it in the mail. On the other hand, if I want to just, for example, move my
cheaper.
Oh yeah, absolutely.
Compared to Amazon.
Absolutely. Yeah, exactly. When you're paying for the network bandwidth too. But on the other hand, if I just basically put my web applications up in the cloud, for example, I can very easily say, okay, my web application is in the cloud, but when it needs the data, I will go to where the data is to get the data and just send the results. If I'm doing a search, I don't need to go pull in all of the data in the world. I just need to find the search results and just give those back to you.
Sure. Yeah, never underestimate the cost savings of SneakerNet and TruckNet versus big pipes, right? So, use case-wise, is this primarily a portability play, or is it a reduction, overhead of instances, or is it a little bit of everything? Like, what is probably primary use cases of? Is it just kind of efficiency in general, right?
All right, so essentially it's different things to different people. As an example, if I'm dealing with a very large number of virtual machines that I'm needing to update frequently, then my pain there is probably the actual management of things. The whole effort to say, I've got these 50,000 virtual machines that I need to go and update once a month. Now that's a real big headache to say I have to go and do that per VM. And then as the number of virtual machines go up, my management costs and effort goes up.
Every touch point is time.
Exactly. On the other hand, if I'm judged by keeping my web servers up and running, then I need high availability. I need to say if this thing goes down within 1 second, I can bring up something to replace it. And so for what we're enabling, it's going to mean different things to different customers. And so it really just kind of depends on, is there a challenge to say I'm running out of capacity in my private data center and I want to be able to spill over into the public cloud as needed, when I get a large flux of traffic? Or is it to say that I want an easier way to manage these things? Or is it that my storage cost, my cost per gigabyte in my data center is very high, and so if I have multiple copies of the same applications, the same workload, that I'm spending too much on the storage? So in that sense, the use case we want to solve is going to depend on the customer's specific problem.
So the other way to look at it is think of it as each one of the VM is an empty cup on the table. They're all the same, they're all empty, they just exist. As soon as somebody picks up one cup, as soon as the person lifts the cup, it will have the content exactly what they want, whichever drink they want. Okay, and the second they put it back on the table, it becomes empty again. If we do that, then what happens is we don't need to create dedicated virtual machines, but anything is available to anybody for any purpose. That's where actually the challenge is, and that's where the solutions are. So that creates the capacity in a different way. It creates an unallocated pool, and it gets on demand. It is provision and then deprovision.
Sure, right. And it reminds me of the concept of, so kind of a growing trend I'm seeing a lot is when virtualization started. Yeah, it was It all ran on the local server, right? And then you needed a SAN to provide that portability. You started needing the network and this, and it grew into this infrastructure that is pretty much just the given baseline, right? But now it's how do you flatten that baseline again, and how do you remove some of those requirements that have come up over the last 5 to 10 years, and how do you, at the end of the day, it's about applications, it's about data, and how do you make that underlying infrastructure more simple? Right. Is that
right?
A simple way to say it?
So you are hitting the very important point for me. What we call ourselves is we virtualize above the operating system, just like VMware virtualize everything below the operating system. Sure. And what is above the operating system? It's your workload. Everything you care about, that's what it is. Your application, your data, your business logic, your licensing, your settings, everything else. So we virtualize that. Once we virtualize that, we are independent of which VM it is in, which hypervisor underneath there, which hardware is there. We unassociate your workload from everything else. That makes the things very mobile for us. The whole industry is going after software-defined data center so that you can move around the bandwidth and the servers and the CPUs and all of that. But what about software-defined workload? That's what Cloud Volume does. Mm-hmm. Software-defined workload management. Complementary piece of software-defined.
And you made a great point here as well that before virtualization came along, I had a bunch of physical servers, and when I wanted to make an update, I'm updating physical machines. Then VMware came along, and I think the original story was primarily about server consolidation, to say, I've got all these servers that are sitting around, not fully utilized. We'll throw them all together into one physical server so that we can fully utilize it. But then that creates some secondary effects. So instead of doing physical server management, I'm doing VM management. And, instead of having... there's a whole set of examples that we have where you kind of look at, this was the problem before virtualization, and it just, now it's VM sprawl is the problem, yes. Right? So, essentially you replace one problem with another, and now just like VMware kind of solved a fundamental problem, there's been a need for something to come along and solve the secondary effects created by having tens of millions of virtual machines.
You're solving the problems going up the stack. And it's interesting that the baseline, we just had a conversation on a podcast that I run with Andre Libovici, and he was talking about, when they originally wanted to virtualize desktops, they talked about, you had a trash can, that Office was based on the original 1970s kind of Office. And I'm thinking, as we have this conversation, that you start with this baseline assumption. So, Windows, you have to have a trash can, right? Because every Office has to have a trash can, and we don't think that way now. Right. So you've changed the conversation. So as you solve one problem, you create a new one. So it's sort of an interesting model. You kind of can't go faster than that. You have to break something to fix it.
Right. And now you're almost coming to the question of, why do I even need a desktop? Kind of continue that analogy. I use a desktop to have a common place to organize my documents or my applications. But what if essentially the moment you need to interact with the file or the moment you need an application, to his point, it just materializes. It's almost like the soda machine. You push the button, you get what you want. So once you kind of enable that, it really becomes a question of, why do I even need the desktop, right? If I can just, the moment I need something, get it within half a second. Because once you go virtual, you can now so quickly bring up resources and move them around that you really have to kind of rethink the way that you did things with physical machines.
So actually, Amy, your point is very well taken. There are 100 million virtual machines out there. It's so easy to create. They don't need hardware requisition. People don't have to purchase it. People just simply create it. Then it has to be managed. And I'm sure your listeners, whoever, many of them has $100 million in their bank account, and they can vouch for it, that how difficult it is to manage. So the world became difficult, and it is still growing at close to 20% a year. So what we are trying to do is take the management out of the virtual machine. You do not need to manage. You do not worry about the sprawl of it. You do not worry about the bootstrap of it. None of them matters, because virtual machine is simply a means to an end for you. What you care about is your workload. So focus on your workload. Let us handle your VM.
Sure. It's a little bit more of So to take it a little bit of, enterprise workloads versus cloud workloads, a lot of people like to use this concept of pets versus cattle, meaning, your pets are the traditional enterprise workloads where it's a virtual machine, it's a server, it has all the apps, it has the data, you name it, you care for it, it requires care and feeding, and it's, you love it. And then there's cattle. And cattle, you don't give them names, you feed them the bare minimum you can, and you know what happens from there. Right? And so it almost seems like, in a way, you're trying to figure out a way to turn pets into cattle, but still keep them pets.
It's a good analogy, because ultimately, no matter...
I don't know if we name them at that point. I don't know
I'm uncomfortable eating hamburgers tonight.
I don't know where we draw the line here. But
Well, so the good thing about our solution...
No, they remain your pet until you have to make them cattle.
Right.
It becomes cattle, and you have no affinity anymore. We'll take care of them.
Right, and so the good thing about our solution, it's basically, it's generic enough that I can look at it in its most basic form, that ultimately, whether it's a pet or it's cattle, it still needs to drink water, still needs to eat food. And so if I can basically provide that basic level of sustenance, then I really don't have to care which one I'm dealing with. And essentially, Cloud Volumes works that way. It doesn't matter if it's a custom application we've never seen before. It doesn't matter if it's a well-known application like SQL Server or Apache Tomcat, or if it's a cloud-enabled application, one of these SaaS services that only exists in the cloud. I mean, essentially, all applications, and all workloads have some common elements that once you solve those kind of fundamental building blocks, you can put anything on top of it.
Sure.
This pet and cattle is catchy. So I have to say one more thing.
So your full credit goes out to Randy Bias at Cloud Scaling. He's universally credited as the original author of Pets versus Cattle, if I remember correctly.
Right.
So I'm giving Randy credit for that one.
Excellent. So your workload is your pet. Yeah. Everything else is a cattle.
There you go. Yes.
Good.
I think that's fantastic. Amy, any other final closing thoughts before we...
Well, I know we talked a little bit about it in the story you led off with. What other trends are you seeing as the spunky startup in this world of enterprise IT? What are some of the challenges you're hearing? What are some of the trends you're seeing? You're sort of in a unique position. You've got a unique viewpoint.
All right. So the single most important thing seems to be the people want to have user manage themselves. It used to be that IT want to have a tremendous amount of control over what they do. Now, what they want to do is do everything, whatever you want to do yourself. However, my data, corporate data, need to be completely protected. That is, and you see that in the cloud all the time. That what is on-prem is extremely important. They don't want their database to go out. But other than that, they have lost the need to control the lives of the user. So
is this the consumerization of IT? We were sort of talking about that. Do you think it's changed our minds philosophically?
Yes. Finally, IT guys have given up. BYODs are going to be there. The devices people will bring. They will have their own applications, everything. First they fought against it. Now they are saying, okay, as long as we can control the right data, the custom proprietary application every large corporation has, as long as they can control their data and their custom apps, they're okay. So I think that is the change. The other change is that the whole licensing model, instead of you buy the application for rest of your life, okay, instead of that, you only need, you pay for it when you need it, and then you don't have it. Yeah. Okay, so pay per use. Metering. Yeah, it is metering is the most important thing, and that's why the rest of the technology has to move along. So that how can it be done metering by actual physical use instead of giving it to somebody for a month? Why? Only when the person double clicks that file, give it to them, and then as soon as they close, take it away.
And also, as things have gone more virtual, IT has a much better idea of who's using what. So, it used to be that I have to go buy 1,000 licenses of something, but, I'm trying to buy at the upper limit of what I think I may need. But why should I actually buy 1,000 if I don't really know if I need 1,000 licenses of something, right? So, to be able to do things kind of like what the cloud also enables, Amazon and Azure and this model in general, where I'm paying per month for what I'm using, or I know at the end of the month I only use 50 machines, not 100, right? So it takes out a lot of the guesswork where you used to have to kind of guess or size what you need. Now you can essentially do that on demand to kind of grow as you need it. And, this whole thing with elasticity is one of these great things that cloud enables. And obviously we fit in very nicely to that to, always know what you're using and only use exactly what you need.
Well, the irony there of letting go of some of the control, they've earned some. So I guess you trade out some pets, you get some cattle.
Exactly. Well, and, I guess it's at the end of the day, to take the analogy even slightly further, the pets require a lot more care and feeding, and IT wants to have the minimal amount of pets possible. I can tell you as a parent, I want the minimal amount possible. So I think that's probably good for this week, and we're running out of time here. We're running up against that kind of limit where everyone stops paying attention to us. So Matt, Raj, where can everyone find out a little bit more about Cloud Volumes and some of the things you have going on?
So first of all, our website, cloudvolumes.com, we have a bunch of demo videos up on there, very short demo videos that just shows you exactly what we do in the various use cases. If anyone's interested to try it out, basically just contact sales@cloudvolumes.com. You can basically try this out. We've got support for all of your major hypervisors and cloud that you'd be interested in. Essentially, we don't really care what the application is. We're agnostic to it. So essentially, if you're having problems managing workloads and managing applications and moving things around, then I think you would find this very interesting.
Very nice. And Amy, you got a lot going on. I think you're going to go record another podcast in like 5 minutes or so, aren't you?
That's true.
so tell everyone where can everyone find out more about you and your other stuff and all of that?
Well, on Twitter, I'm at Comms Ninja. We do a podcast with John Troyer and Matt Brender called The Geek Whisperers. So find us at geek-whisperers.com. And if you're interested in whiteboarding as a service, engineersunplugged.com. I run a weekly video show.
Yeah, you've got a lot going on.
I'm a little busy.
All right, everybody. If you like the show, please tell a friend or leave us a review on iTunes. You can also follow us on Twitter at @thecloudcastnet or on the web at thecloudcast.net, where you can find links to everything Cloudcast. Thanks for listening.